Okay, so let's continue our previous example and find out how to get to our $1.8 million retirement amount. So we draw a picture again, is $1.8 million is how much we need at retirement, so we can withdraw at $100,000 per year and leave an estate of $250,000 so we don't run out of money. Well, what we're looking for is how much return we need on the amount of money we've already saved. So if you haven't saved anything, of course, this is going to be zero. If you've saved something, it's going to be positive. So let's say in this case we have $20,000 saved for our retirement, and what we're trying to do is get to $1.8 million. You can already see where this is going. It's a simple time value of money calculation. So let's look at our variables. We have N, I, PV, PMT, and FV. In this case, N is the age 65 of our retirement, and in this example we're 35 years old, so N is 30. I is the rate of return, or the slope of this line of our current savings to our future savings, so the rate of return is what we're looking for. The current present value, as you know, is $20,000. The payment is how much we save per period going forward. In this example, we're going to start with not saving anything. So if you don't save anything additional for your retirement, we're going to run one set of numbers for that. And our future value is the $1.8 million that we're looking for. And we, of course, know that that needs to be put into the calculator as a negative number. So if we use the calculator for this, 1.8 million is a withdrawal. So the $20,000 will be positive, any payments will be positive, the 1.8 will be negative, and of course we're just looking for our rate of return that we need on our $20,000. So we grab our calculator, turn it on, clear second, clear time value of money, and we do N, or 30N. We need I, which we're looking for, so we don't have any input to I. Present value is what we've saved now, which is $20,000. The payment is 0 in this example, and then of course it's $1.8 million for future value. Oh, I got to remember to put it in negative. So if you put it in positive and you need to change it, just hit the plus minus key, turns it into a negative $1.8 million or withdrawal, and then just hit future value again to put it in the register. And then we simply do compute I. In this case, it's 16.18%. So I is 16.18%. And so what this says, if we put it back into words, is in 30 years, $20,000 compounded at 16.18% will add up to $1.8 million and be able to fund our retirement. Of course, 16.18% is a very high rate of return, and you're probably not going to get that. So let's back into a different number, which is our payment. How much do I have to save so I can use a reasonable rate of return to turn my $20,000 into $1.8 million? So in this case, we do 30N. We use a rate of return that we think is reasonable. A common rate of return over a long period of time for stocks is somewhere around 10-11%. So we're just going to use a number here, a round number of 10% for our rate of return. Our present value, of course, is the same, 20,000, and of course we're still looking for 1.8 million. Now we know in our financial calculator that most of these numbers are already in the register. We know that N is 30, it's already in there. We want to change I to 10%. The present value should be in there. The future value is in there as well, and so we're just looking for compute payment. $8,821 is our payment. $8,821. So what this says is if we start with $20,000 today and we compound that at 10% and add $8,800 or $8,821 to our account every year going forward for 30 years, at the end of 30 years we end up with our $1.8 million retirement amount. So maybe $8,800 is the ability, a number that you can save. Maybe it isn't, but that's the number at 10% return that you need to have deposited every year for the future value of $1.8 million to be available for your retirement. Also, this assumes a 10% return. Maybe we don't want to take the risk that would be required to try to get a 10% return. So let's look at this at 8%. If we just change the I to 8I, compute payment, it's $14,000 $112, which is what we would need in additional deposits for an 8% return starting with $20,000 over 30 years to end up with $1.8 million. You can see how easy it is to play with the variables to find your own situation. So these are very simple calculations to do once you understand time value of money and think about what your situation is trying to get to your retirement amount from where you are now. Usually the set numbers are your present value. How much you've saved today is usually a set value, and you've already run calculations to get a future value or the number that you're trying to get to. If these two are set, you can adjust your time. Maybe you want to work a little bit longer. Instead of 65, maybe you want to work to 67. Well, instead of 30 years, we just change that to 32 and run the same calculation. So let's look at these numbers at 32 years in retirement. And let's go back to our 10% example. So we do 32N, and we go 10 for I. We know we can hit recall present value. We know it's still $20,000. We can hit recall future value. We know it's still $1.8 million with the negative sign. And then we just compute payment, and it's $6,849. So if we change our retirement and just push it out to 67, which is 2 more years of working, which we may not want to do, but it's at least a calculation we should do. We have a 32 years in our working life with a 10% return, starting at $20,000, getting to $1.8 million. We need to save $6,800 a year going forward. So you can play with these numbers to find out what fits your scenario. You can adjust any of these variables to see different scenarios in your own life. And once you understand that where you start and where you want to go is the method to finding out what the calculation should show you, you can adjust it for your own situation.